Hi, welcome back. Hononegah Honors, Algebra 2, Section 1.3. We previously did Section 1.3 AC, or alternate content. So this slide that you're seeing right here is the exact same slide you saw before. If you know the slope and the y-intercept, you just then can write an equation of a line using slope-intercept form. If you know the slope and a point, then you need the formula, the point-slope form, to write an equation. And if you know 2 points, you need the slope formula. And then once you have established the slope formula, now you use a point and a slope to write an equation. So again, this goes back to 1.3 AC. So the graph shows the distance Allison hikes in X hours. Write an equation of the line and interpret the slope. How long does it take Allison to hike 14 miles? So again, they want you to write an equation first. You know 2 points. You know 0, 0, and 7, 24.5. Now this isn't going to be very friendly, but 24.5 minus 0, 7 minus 0. So again, this would be the slope. So the actual slope of this is a pretty decent decimal, 3.5. So now the slope is 3.5. The y-intercept is at 0, 0. So the slope is 3.5x. So what is the slope? They said interpret the slope. Well, Allison is hiking. We got y equals 3.5x. Well, what that means is Allison is going 3.5 miles per hour. That's how fast Allison is hiking. So now, how would I figure out how far she would be at 14, or excuse me, how long it would take her to go 14 miles? Well, I would plug 14 in for, whoops, hold on for a second. We're trying to find how long. The x is the hours, and y is the distance. So 14, 3.5x, divide by 3.5, and I would get 4 hours. Now let's look on the actual picture and see if that makes sense. 14 miles would be about here, and it is 4 hours. So again, using the equation to calculate how long it would take. Kelly and Kim are both babysitters. Kelly charges a flat fee of $10 plus $6 per hour. So here's Kelly. Y equals 6x plus 10. The table shows the hourly fees for Kim. So here's Kim, and we don't know Kim's equation yet. So for 1 hour, it was $22. For 2 hours, it was $26. So now let's write an equation for Kim. Y minus y over x minus x, we end up getting 4 as your slope. Using one of the points, so let's say I use the point 122, it'd be y minus 22, 4, and then x minus 1. And then I add 22. So Kim's equation is y equals 4x plus 18. So here's Kelly, here's Kim. Who charges more per hour? Who has the higher slope? Well, Kelly charges more per hour. Kelly charges more per hour. How many hours must Kim and Kelly babysit for their totals to be the same? So they want to know, and I'm going to scroll down here to make this, they want to know when is the two, Kelly and Kim, equal. So solving, I subtracted 4x and then I subtracted 10. So after 2 hours, whoops, let me try that again. After 4 hours, they would have charged the same amount. And then beyond that, Kim would actually be cheaper and Kelly would be more expensive. Scatter plots. Data does not always show an exact linear relationship. So when you basically collect some data, it won't make a straight line exactly. So here's the steps you would do for a scatter plot. 1, create a scatter plot using the data. Sketch the line most closely to represent the data. This is known as the line of fit, or sometimes referred to as the line of best fit. So you're going to draw in a line. Choose 2 points that end up on that line. Estimate those 2 coordinates. Then write an equation using the 2 points. The table shows the amount of fruit used to make a smoothie in ounces and total cost. Does the data show a linear relationship? All right, so we're going to graph these points as best we can. Now, going across, we can go by ones. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Now, increments going up. I would say we need to go in 50-cent increments. So this is $1, go up, that'd be $2, $3, $4, $5, $6. And that would take up all of our data then. So now we're going to graph these points as best we can. So again, just be close. 2, 210. 1, 150. 4, 305. 7, 445. 10, 595. 3, 170. Whoops, 175. I'm going to have to erase that one because I was off there. 3, 175. 6, 4, and I can see I messed up there. It's 7, 495. Maybe somebody saw that already. And then it's 9, 535. Okay. Now, is this an exact straight line? No, it's not. But does it look fairly linear? Meaning, does the points make close to a linear? Yes, it does. So I'm going to draw a line through the middle of the data as best I can. So again, trying to go right through the middle of the data as best I can. And there should be some points above and some points below. And it looks like I've got a couple of points here that might not be too bad to use for my equation. So it looks like this one looks like a good one. And how about this one down here? So the 2 points that I picked were 6, 4, and 2, 210. So I'm going to get a slope here. So y minus y over x, x minus x. So 4 minus 210 would be 190, or 1.9, sorry, over 4. So I'm getting a 0.475 slope. Now pick a point, and I'm going to pick the point that doesn't have a decimal to make my life a little bit easier. So y minus 4, 0.475, x minus 6. So I'm going to get y minus 4 equals 0.475x minus 2.85. Add 4. And so I'm going to get y equals 0.475x plus 1.15. All right. Does the data show a linear relationship? We're going to say yes. If so, write an equation of the line of best fit and use it to estimate the total cost of a smoothie for 8 ounces. So I'm going to put 8 in for x now. So 0.475 times 8 plus 1.15. And so we are estimating if you had 8 ounces of fruit, that would get you 4.9. It would cost, $4.95. Look at your graph. I'm just going to go up on my line here. 8, is that about $4.95? So we are estimating where 8 would be using the equation. Now, this is a pretty inexact way of doing things, okay? Meaning I drew that line in, I picked 2 points. So on a test or a quiz, a lot of times I will tell you which 2 points to go ahead and use in your scatter plot. So now the line of best fit is a line that lies as close to possible to the data. Many technology tools have linear regression features that will do the line of best fit for you. The correlation coefficients denoted by R is the number of -1 to 1, which measures how good the line is. When you get an R value, the closest you are to 1 is, if it's exact, everything fits on the regression line or the line of best fit, the R value would be 1. If the R value does not fit on it, the closer you are to 1, the better the line is. So now, I'm going to pull up a graphing calculator. If you have a graphing calculator, you need to pull it out now. Hit pause if you need to. All right, so I'm going to pull up a graphing calculator, and I'm going to put this set of data into a graphing calculator. So let me get my graphing calculator up here. Sorry, there we go. There's my graphing calculator. Here's the steps you want to go to. You want to go to STAT, S-T-A-T. Hit enter on edit, and it's going to have lists. And I notice that I already put the numbers in, but you are going to go, you're going to put in the number for the X column and a number for the Y column. And so what I did was I put all the data that's here into my graphing calculator. So take a few minutes, hit pause if you need to. All right, so now we have our data put in. Now we want the calculator to actually come up with the line of best fit for us. So we're going to hit Stat, and instead of Edit, we're now going to go Calculate. And one of them is called Linear Regression, number 4, L-I-N-R-E-G, number 4. So number 4, whoops, I went too far, linear regression. So I'm going to hit enter. Depending on your calculator, it's going to ask you some questions here. Some of your calculators, it's not going to ask you any questions. You just have to hit enter. Some of it, you're going to have to hit enter until you actually get down to calculate, and then you're going to have to hit enter. So now, what this is telling me is for a y equals ax plus b, the a value is 0.50546, and the b value is 0.86506, obviously stopping at that point. So now I want the calculator to do something for me. Okay? I want to go to y equals, and now this one's going to require a little bit of work. I want to go to vars, statistics, number 5, equation, and so now it's putting that equation into the calculator. So I'm going to hit enter. All right, and I'm going to show you some more stuff to do here. Let's say I wanted my points, okay, the actual points. I'm going to go up to plot and turn my plot on. And then I'm going to go to window. Now the window, basically, how big do you want your window to be? I want my window to be from 0 to, let's go 15. So the x values of my smoothies went from 0 to 15. And the y values, let's go from 0 to, let's go 10. Hit graph. Notice, it made a scatter plot and drew in my line of best fit. Now, I want to know, I want to answer the question, the same question that I answered before. I want to know what would 8 be for my linear regression. So here's what I want you to do. I want you to hit second, trace, and you want to find a value. What value do we want? We want 8 ounces. Hit enter. And notice, using the linear regression equation, it got 4.9. So that's a little different than when we did it by hand. Obviously, this is way more accurate. This is exact. Okay, it's round, it's going to way more decimal places than what we did when we did this by hand. So compare the cost to example 3. So if I went back to example 3, I thought it should be, the calculator says it should be, I'm going to go back over here, 4.91, and when I did it by hand, I ended up getting 4.95. So pretty good. Like my estimation is pretty good when I got $4.95, and then with the calculator I end up getting 4.91. Homework assignment, page 26, 3 through 15. Okay, use 13 and 16, use those points. So in question 13, use the point 16 and 1150. In question 15, use the point 761 and 1726 when writing your equation. Now, if you really need a graphing calculator to do these, I want you to do them all by the graphing calculator. I do not want you to do it by hand. So I want you to answer the questions with the graphing calculator only. Good luck. If you have questions, make sure you ask. The calculator can be a little bit confusing because it might be the first time some of you have actually used some of those functions.